To class, this is Mr. Ryan on the second week of Wednesday, which is 4/8, April 8th. And remember, you started your test Tuesday. You had a whole day on yesterday to do it, and you'll have until Thursday to turn it in. So today we're going to start in our new chapter 13.1, Counting Principles, and this starts on page 560. So to get used to this now, we're going to start looking at how many different ways we can do things, which is the basic idea of counting principles. So example 1, how many different passwords are possible when the password contains 3 case-sensitive letters, meaning they could be both upper and lower case, followed by 2 digits? Well, there's 26 letters, but I'd have to double that to be upper and lower case. So the first would be 52 possibilities times the second letter would be 52 times 52 for the third times 10 for the digits. And multiplying that all out on the calculator comes to the very large number, 14,060,800. Now example 2, how many different ways can the letters A, B, C, D, E be arranged? Well, the first letter could be one of 5, the second letter could be one of 4, the third letter could be one of 3 that's left that hasn't been used, the fourth could be one of 2, and the fifth there's only one left. So the way we multiply this out is 5 times 4 times 3 times 2 times 1, which is 120, and we have a special name for that kind of multiplying called 5 exclamation point or 5 factorial equals 120, and that's all we need is the exclamation point. Okay, and so in general, n factorial is equal to n times n minus 1. They all have to be integers, times n minus 2, multiplying all the way down to 1. But where we find some cases we need 0 factorial and 1 factorial, both of which are defined to be 1. Now in example 3, if we have 8 students, how many different orders can they finish in a race, say for instance? Well, that would be 8 factorial, or 8 different ones could finish first, 7 different ones could finish second, 6 and 5 and 4 and 3 and 2 and 1 and so on. Multiplying all those together gives me 40,320. But now, coming to something that we'll do more of, if 8 students run a race and awards are only given for first, second, and third, then the arrangement of the last 5 finishers doesn't matter, because we don't care who came in 4th, 5th, 6th, or 7th, or 8th. So this would be 8 factorial divided by 5 factorial, meaning the order of the last 5 is divided out. So it would be 8 times 7 times 6 times 5 times 4 times 3 times 1 divided by 5 times 4 times 3 times 1, which would be just 8 times 7 times 6, or 336. Now we have a special way of doing this because this comes up a lot. So this is the number of permutations, which has to do with order, of 8 items arranged 3 at a time, symbolized as 8p, capital P3, or 8 factorial over 8 minus 3 factorial. That's the form for it, and that's what we just did, is 336. So the definition for this is the number of permutations, which has to do with order, of n objects taken r at a time is npr, which is n factorial over n minus r factorial. Now in example 4, how many ways can 5 of your 9 favorite photographs be arranged in a line on a shelf? So this would be 9p5, and again, we don't care how the last 4 are arranged. It's just the first 5 that we're concerned about for order. Order is permutations. So 9p5 is 9 over 9 minus 5 factorial, or 9 factorial over 4 factorial, which just leaves us with 9 times 8 times 7 times 6 times 5, with the 4 factorials canceling each other out, and this multiplies out to 15,120. Now a new definition, the only other one we'll have today, is a definition of combination now. Doesn't have to do with order. It's a collection of objects in which order is not important. the number of combinations of n objects taken r at a time. Now this looks similar, except it's ncr instead of npr. And you'll notice instead of just having n factorial over n minus r factorial, we have an additional r factorial. That's to say the r objects at a time don't matter, like just being in a group with who cares what order that you selected. But this is equal to npr, what we looked at before, again, divided by r factorial to make the number of r objects not matter the order. Now in example 5, we can show this as find the number of different 5-man teams that can be made from 12 players. Here the order of each team of 5 doesn't matter, that's the 5. So this would be 12c5 or 12 factorial over 12 minus 5 factorial divided by 5 factorial, the 5 in the team. So that's 12 factorial over 5 factorial, 7 factorial, and that comes out to 12 times 11 times 10 times 9 times 8 times 7 factorial over 5 times 4 times 3 times 2 times 1, 5 factorial, and the 7 factorials cancel. So that's 95040 over 120, which is 792. Now this next one's a little harder one. Example 6, how many different pizzas can be ordered by choosing up to 3 of 8 individual toppings? Well, one way would be having 0 of 8 individual toppings. Another way would be having 1 of 8 individual toppings. Another way would be having 2 of 8, and the last one would be having 3 of 8. So we have 8c0 plus 8c1 plus 8c2 plus 8c3. Each time the number of toppings, the order of them picked, 0, 1, 2, or 3 doesn't matter. So the first one is 8 factorial over 0 factorial times 8 factorial, which is just 1. 8c1 is 8 factorial times 7 factorial over 7 factorial times 1 factorial, which is just 8. 8c2 is 8 times 7 times 6 factorial over 6 factorial divided by 2 times 1, or 56 over 2. And 8c3 is 8 times 7 times 6 times 5 factorial over 3 factorial, 3 times 2 times 1, with the 5 factorials canceling. And that leaves us with 1 plus 8 plus 28 plus 56, or 93. Now for the homework starting on page 562, this is just counting how many possibilities. How many sandwiches can be made by selecting one of 3 types of bread, 4 types of meat, and 5 types of cheese? Well, that would simply be 3 times 4 times 5 possibilities, or 60. Just how many different possibilities. Same with problem 4. 5 flights to Denver, 6 flights to LA, and 3 flights to Hawaii would have the number of different possibilities of flights on those 3 lines would be 5 times 6 times 3, or 90. Now this one is a little long and we're trying to illustrate it with a diagram. There are 3 balls in a box. All 3 are drawn one at a time and aligned up in order of the draw. If the balls are blue, white, and green, list the possible different orders and state how many there are. Well, for the first draw, we're either going to get a blue, a white, or a green, and that has the number 3 under it. For the second draw, we get a white or a green for the blue, we get a blue or a green for the white, and we get a blue or a white for the green. So that's times 2. And the last ball, there's only 1 left. So for the top, it's going to come out to blue, white, green. The second pick would be blue, green, white. The third pick would be white, blue, green. The fourth pick would be white, green, blue. The fifth pick would be green, blue, white. And the last 6th pick would be green, white, blue. And these are all indicated by the diagram and by the 3-letter name after the selection is made. So this would be 3 times 2 times 1, or 6 possibilities. Now we'll go through some easy ones using what we just learned about permutations and combinations. 8p3 is just 8 factorial over 8 minus 3 factorial, which is 8 factorial over 5 factorial, or 8 times 7 times 6 times 5 factorial over 5 factorial. Those cancel, leaving us with 336. Now 5c2 is 5 factorial over 2 factorial times 5 minus 2 factorial, or 5 factorial over 2 factorial times 3 factorial, or 5 times 4 times 3 factorial, over 2 times 1 times 3 factorial. The 3 factorials cancel and we get 20 over 2, or 10. Now for 12, we have 6c5, which is 6 factorial over 1 factorial times 5 factorial, which allows us to do this same thing, 6 times 5 factorial over 1 times 5 factorial. The 5 factorials cancel, leaving us with just 6. For 14, we show this case of the 0 factorial by looking at 5p5, which is 5 factorial over 5 minus 5 factorial, which is 5 factorial over 0 factorial, which is 5 times 4 times 3 times 2 times 1, over 1, which is 120. But now, because of the way things are defined, 5p4 is 5 over 5 minus 4 factorial, which is 5 factorial over 1 factorial, and because 1 factorial is also 1, it's 5p4 is 120, just like 5p5 is. And so in general, we can say npn is equal to np n minus 1, because of 0 and 1 factorial being the same as 1. Now, how many different 3-letter words can be formed from the letters A, K, L, M if the letters can be used more than once? Well, the first letter has 4 possibilities, the second letter has all 4 possibilities, and the third letter has all 4 possibilities. So 4 times 4 times 4 is 64, because all 4 of the letters can be used in each position. Now in 18, how many different license plates can be formed containing 3 digits followed by 3 letters if the letters and digits can only be used once? Well, the first digit is 10, but we've used 1 digit, so there's 9 left for the second and 8 left for the third. Similarly, for the first letter, there's 26, but in the second letter spot, we'll only have 25 because we've used 1, and in the third letter spot, we'll have 24. So multiplying those 6 numbers together, we get 11,232,000. Now on 20, how many dinners of 1 meat, 2 different sides, and 1 dessert can be ordered from a cafe offering 5 meats, 6 sides, and 1 dessert? Well, this would be 561 for the meats times 6c2 for the sides times 4c1 for the desserts, or 5 factorial over 1 factorial 4 factorial times 6 factorial over 2 factorial times 4 factorial times 4 factorial over 1 factorial 3 factorial, which the first one, 5c1, just comes out to 5. The 6c2 just comes to 6 times 5 over 2, and the 4c1 comes to 4. So 5 times 30 over 2 is 15, times 4 is 300 possibilities. Now 22, if a committee of 5 people to be appointed from a group of 12, how many committees can be formed? Well, we've done this one before, 12c5, 12 factorial over 12 minus 5, 7 factorial times 5 factorial. And notice we can do 12 times 11 times 10 times 9 times 8. And the 7 factorials, top and bottom, will cancel. But we also have left a 5 factorial on the bottom, 5 times 4 times 3 times 2 times 1, which comes out to 95,040 over 120, or 792. And for our last 2 homework problems, how many ways can the letters in the word mother be arranged? Well, that would be 6 different letters, which would come out as 6 times 5 times 4 times 3 times 2 times 1, or 6 times 5 factorial, which is 6 times 120 or 720. Now the last one here is if the American Literature reading list contains 20 classics, how many ways can Jared select 4 books to read? And here the order doesn't matter, so we use combinations. So that would be 20 C4, so that's 20 factorial over 20 minus 4 factorial times 4 factorial, which would be 20 times 19 times 18 times 7 times 16 factorial over 16 factorial, and then divided by 4 times 3 times 2 times 1, or 116,280 over 24, making 4845. And this is the end of Wednesday, April 8th. God bless you one more day, and then we have Easter. I know you love that, and so do I. God bless you out there, keep you healthy and keep you safe. And God bless you in Jesus' name. Amen.